Right, just a little project here out of some scrap. Found this board here in a skip. It's this sort of nylon, it's got a little face side there, look. It's this sort of nylon, hard wearing, sort of surface finish. I suppose you could use it for sort of abrasion resistance, wipe down surfaces, stuff like that. But it's a sort of nylon base, the sort of thing chopping boards are made from, and it's non-conductive. I've checked it with my meter. So I'm going to make these things initially for my radials on my quarter wave vertical. I've got raised radials which I use here permanently in the garden, and at the moment I've just got the ends tied in the bush, as it were. So I'm going to make these, make it a little bit more professional. So just cut some strips off like that. These are about 100mm long, just about 4 inches, and then I've cut 2 holes here and 2 holes there, and I've countersunk them slightly. And then this one here, the end one on one end, I've just put a slot in to the hole. So my plan is that the radial comes in here, through one, through the other with a knot in the sort of standard way, and then I've got a hole if I want to put a permanent sort of piece of string, a line through there to tie off. Or I've got this slot here, so I can use it more like you would a tensioner for like a guy line or something like that. So that'll become more apparent in a moment when I go out to the garden and demonstrate that. But for now, I'm just finishing these off. Gonna, with a bit of sandpaper, just take all the burrs off, things like that, just to make them a bit neater, and take off the protective layer off the face side. So next then I'll be out in the garden installing them on my radials. Okay, right, here we are in the tree, and using the brown wire in this background, that's probably never going to come out on the camera, is it? Anyway, so let's just see here. So there you go, 2 holes, come up through, around through the other one, and just a little thumb knot there. So I can put a rope through there, tie it off, or I can use this to come back on itself and form a loop like that if need be. So if I can just say come around here, so I can come back on itself, look, like so, and then I can just slide this along to tension that up, and that will be, as you can see, that takes a tension there, no problem at all. That stops that sliding back. So that's one way of doing that end. Right, here's a junction with my counterpoise. So this is coming from an antenna, and then they split off, got a blue one going off there, and this old earth wire, yellow and green here. And it's sort of, as I pan round, as you can see, it sort of slopes off and then sort of goes up again in where I've got it tied in the bush. And so that's not particularly good really with the capacitance with the ground, because that line, you know, it varies in height. And if you've got a NanoVNA or something like that, it's quite interesting to have that plugged in and analyze your signal when you muck about with your raised counterpoise or radials. And so in an ideal world, that wants to be straight to give me a consistent capacitance, really. That's the way I see it anyway. And to get it straight, I've got to have a bit of tension. So that's the other reason of trying to design, well, making these non-conductive ends. So just untie it from the bush here. I just had it roughly in there. Okay, so this one I've just got a random bit of rope here, just through in a little knot, so I can put this one on, through that one, back through that one, Another little overhand knot there to stop a knot of your choice. Okay, so just like before, this can come round back on itself, and I can put that somewhere, and that's going to give me plenty of tension, and of course it's fully adjustable. There you go. But also I can just tie that like so. If I want to change the angle of this and bring it away out to my right or something, then I can. So I'm going to do that now. I'm going to find an appropriate place in here somewhere. Yeah, something like that will do. Okay, so now if we sight along that yellow line there, that bit of counterpoise, that's nice and straight, slightly sloping down, which is what I'm after. And that will actually have changed my effectiveness of the radiating element without a doubt, with the return loss on the NanoVNA. SWR will probably stay the same, but these little changes do make a difference in this sort of static can't even say it, in this static configuration. So well worth doing for your home sort of QTH setup. So there you go, that's much better. That's really consistent now, and of course because it's tensioned the whole sort of system, the other one, which is going the opposite way here, this blue one, is nice and straight as well. Okay, so just checking now the SWR and the return loss. Outside at the antenna on 40 meters, I've got my NanoVNA here. So at the bottom you can see the SWR, the curve at least, and at the top left you can see it's 1 to 1.1. We've got 49 ohms there, and on the top right it's minus 24 dB. Which is that line there. So let's go and play with the counterpoise and see if I get a better return loss. You can see the SWR is quite low across the band there. That's 7 megahertz to 7.2 megahertz, and yeah, it would be nice if that curve was probably in the middle a little bit more, but what's our frequency? We're 7.038, so that'd be alright if you're on CW, but hey, yes, I'm not too fussed about that. Right, I'm going to go and play with the counterpoise, see what happens. Okay, a couple of minutes later, and as you can see, that return loss, the I think it's magenta colour, the curve there has got a much bigger dip to it. That's the great thing with the NanoVNA, is that you got real-time readings of what you're doing. So if I just move this across a minute. So what's happened is I've raised my elevated radials, the ends of them actually, I'll show you in a minute, to about 1.5 meters, almost sort of chest height. And I've got a better dip there, and also the SWR and everything has moved up slightly. So looking at the top SWR, oh, that's 1 to 1, isn't it? Still got our 49 ohms impedance, and at the top there you can see we've got minus 33 dB, much more of a dip there. So we've improved on our return loss, and our frequency, resonant frequency, is moved up, I don't know, what's that, 50 odd plus to 76. And essentially we've got a flat SWR across the band there. So yeah, there you go, infinite messing about if you've got one of these type of pieces of kit. It'd be nice to get that further along again,
probably won't be able to because the length of my radiating element, but there's no reason why I can't try and muck about again. I know I'll be very happy with that there. Now in the middle, I suppose that's the impedance curve, very short and small one, so that reflects the low SWR curve, and it means I'm probably going to be 10, I don't know, 5 or 10 ohms either side of 50, so everything is pretty much matched and tuned, I'd say. Pretty happy with that. It'd just be nicer, if you like, if that resonant frequency was a little bit higher up the band for me, because virtually all my operating on 40 meters is SSB voice. So but anyway, let's go and have another play to see if I can improve that. Probably not. Well, I tell a lie, I can improve it again. So you can see where we were, 7.078, and raised the counterpoise or radials yet again. So let's just move this over, screws, fingers and thumbs here. Right, let's get right in that dip, about there somewhere. Oops. So now we're resonant at 7.130. Okay, maybe a little bit higher, and we have got minus 36 dB, 1:1 SWR, 49. So yeah, very happy with that. And NanoVNA there. I've got about 4 meters of coax, which is comes up to my choke here. These are ferrite beads around the RG58 coax, and then it goes into my transformer box. Now I've got a transformer box because I've got a transformer for 20 meters, because that radiating element there is half wave end fed for 20, so I've got the toroid and everything in there. But this is a bypass, so that's 20 meters, this is 40 meters, so into there comes out on the right hand side of the box. I just swap the radiating element over to this side, coax over to this side for my half wave end fed. But when I do that, I also disconnect the radials, which I've just adjusted, and I've got these really nice, if you just focus here, these banana plugs, inline banana plugs, that just pulls apart. So yeah, there you go. So I just have a couple of meters coming out of the box both ways, just to help with common mode current really. Plugs into there. There you go, like that. That now connects up my radials, and for a long time I've just had them at sort of waist height, sloping down. But I don't know if you can see here, but this is nigh on, just about, this is my shoulder, which I can measure later. That's about 2 meters up there, so that's going to be I don't know, 1.5 meters plus. And of course it depends on the ground and where you're at. So there you go. Hope that all came about by making these ends for my counterpoise. This one that I've got just stuffed in the tree here saves me making a knot. This is the other side. So I've just got that there. So counterpoise and streak there. So it goes off around the bush, comes back, and I use the notch there just to tie it off. So that's the little setup. And just goes to show counterpoise, raised counterpoise make a massive difference. Obviously there's some sort of weird capacitance thing going on with the ground and stuff like that. Okay, I'm just going to check again now my 20 meter element. Well, I suppose once you start checking these things, you start to get a bit of mission creep, don't you? So I've just swapped over to the 20 meter input there, coax coming in, transformer, antenna going out. You can see the other side here, that's my 40 meters coming in. It just point there, it comes in here, just bypasses completely and up. And I've got my grounding in here to go out for the counterpoise. So yeah, just put it on the VNA and I'm basically resonant out of band, which it definitely wasn't when I first made the thing, interestingly. So where are we? We are at exactly at the bottom of the band, 14 megahertz. There's still the curves at the bottom, SWR. In the middle there we got return loss of minus 34 and 51 ohms. So that was in the middle of the band nigh-on. That was at 14,200. That would imply that something's got longer. To bring that up in frequency, obviously you have to, normally you would reduce your radiating element. So I wonder if over time this antenna has been up a good while now. It's a 12 meter spider pole. Whether or not that's just gone a bit long, I don't know, maybe. It's a lovely spring morning, but it's only about 5 degrees. It's quite cold and a bit windy, so if anything it's going to be at its shortest if it does move with temperature. Nothing's moved in there because I once I got these windings correct, I have sort of put a dab of super glue on them, and obviously there's sort of mastic holding it all in place. But maybe it's condensation or something, that I don't know, but everything seems to be in place. There are no dry joints have appeared or anything like that, and obviously it's working, so there is a match, but it's not at the right frequency. But what I can do is, the capacitor on this type of design is a piece of coax, which is just trimmed to the right length. So I'm just going to find the end of that, which is comes around here, down here. I'm just going to snip off a bit of this, because that will raise my resonant frequency. So let's see what that has done. Okay, so there you go, you can see the cursors are still in the same place, but the curves have moved up. Got way more return loss there, so let's just see what frequency that is at. I just come up, oh, go back one there. So we've come up 60, 41 return loss. So yes, let's keep going a little bit more. I trimmed off about a couple of millimeters then. I'm going to keep going. Got nothing to lose. Okay, a final trim there. Haven't changed anything in there. Same setup as before. And let's see what we got. So it's just about steadied there. We're on 14, called it 14.2. 1-to-1 SWR, 49 and a bit ohms. Return loss 42, 43. It's jiggling around a bit because of the antenna moving. So at the bottom you can see the curve there, SWR curve. That's across the whole band, nice and low. So around about the middle of the band for SSB phone, pretty good numbers. One other thing to note is that I've adjusted that again with these short counterpoise here, which part of the design just for a common mode. there at the new height that the 40 metre is tuned at. So now that I've done that, put a bit of tape on the end there just to clear that up, put the cover back on and recheck everything finally. Okay, taped up and cover back on, set up as would be in operation, and all the numbers are the same, so happy with that for 20 metres, half wave and fed. Now set up for 40, coax on the other side, radiating element on the other side, and both sides of my radials connected. Let's see what we've got. We're back in 7.146 roughly. We've got -36, SWR 1:1, 50 ohms. Okay, so that's in the middle of the sort of lower side band phone. If you wanted to bring that resonant frequency down a bit for CW and digital modes, all I have to do is just adjust my counterpoise. And as an example, you see where we are there, frequencies 7.146. I bring this counterpoise here, it's coming out, it's almost horizontal there, it gets hooked up in this little tree, then disappears off. I'll even move this down. Bring this down to here, so I've moved that probably just this end down like that now. Okay, bring it to here. Let's see. You can see that the resonant frequency is reduced. So both SWR and return loss. So if I just move the cursor down a little bit, we'll follow where that is. Sort of there. That's 0.132 now, maybe a little bit more. So interesting stuff with these raised counterpoise, and so dependent, I'd imagine, on your ground where you're set up, and possibly the weather. So if you're really into it, you're probably going to be messing with this forever and a day perhaps. But yeah, let's just put that back up there, a bit more level. Probably where I mess about in the band. Right, so yeah, it's gone back up again, isn't it? So let's move that again. It's about there. Yeah, there you go. That's pretty good. Pretty cock on. Happy with that. Proof of the pudding now is to get on air, see what happens. So just as we switch on, the usual. Contests. Dear oh dear. Oh.
Hello, contest, CQ,
Contest.
CQ, Charlie Radio 3DX, Charlie Radio 3 David X-ray, contest.
There we go. Contests. CQ contest. Contest. Man alive, every weekend. VK3XSY, well, it's easy enough to receive Australia. The trick is to shorthand transmit, isn't it? And it's been the right time of day and everything, so we're probably a little bit late on the grey line. And there's much bigger stations than my 10 watts at the moment, but something to work on. But of course, I've got it on the 20 metre antenna at the moment, but that doesn't stop me from listening on 40. So we'll just switch the VFOs and tune around what's that, the Netherlands. So yeah, and so you can listen that way. So yeah, just nip out, swap over, and change bands that way. I've got about 20 metres of old RG58 coax, ex-military coax, must be 30 or 40 years old, so I'm not doing myself much favours there. But yeah, it's all part of the hobby, isn't it, to gradually improve and work out all your little inefficiencies. So only running 10 watts, you got to trying to maximise everything, really, haven't you? So see if we can tune around and get some contacts. But on 20 metres at least, there's a contest going on, which is great, isn't it? Usual weekend contests. They should certainly have part of the band that you shouldn't have contests on, but there you go, that's another story, isn't it? Alright.